In this lecture, we will start talking about Chapter 7. Chapter 7 is the last chapter we will cover in 1440, and it covers the topics arrays and the array list class. For us in 1440, we are just concerned with the arrays. We are going to cover arrays, and we will leave array list class for 2440. So as you move to 2440, the first thing will be covered there is a quick review of arrays, and then you will move to learn new topics there. So what is an array? An array is a data structure, and when we say data structure, it's a structure to organize data, which is very obvious from its name. And there are so many data structures that can be used. And arrays is the most basic form of a data structure. So in its simplest form, it's a one-dimensional structure that looks something like that. So it's a way to organize data in a way that we haven't covered before. So far, we learned how to define primitive data types. Primitive data type, each variable holds one value. In an array, what you want to do is to store multiple values in a structure like this. All right, so that is so n of these could be stored in a way like this. So that is a single entity. That could be array x, all right, which contains n data points or values stored next to each other in that way. So that's what an array is in its simplest form. All right, so to motivate the reason of why do we need arrays, let's think of this very simple example. We have a temperature converter that is going to take a value in Celsius, and what we wanted to do is to go and convert that into Fahrenheit, the equivalent Fahrenheit temperature. So that's what we're doing here. We are declaring two double primitive data type values here, parameters or variables, ctemp and ftemp. Ctemp represents the temperature in Celsius. Ftemp is going to be the equivalent of this number after sending the 10 to C2F method, which is going to do the conversion and bring us back the equivalent temperature. If we go and have a look at C2F, C2F has an input double C, which is then applied to this equation, and then it's going to calculate that new double value and return it as a return data or the return value from this method, which is then going to be stored in ftemp. Using a print line and printf statements, we're going to print Celsius tab Fahrenheit and then the temperature in Celsius equivalent in Fahrenheit with a single tab in between them. And these values are ctemp and ftemp, as we can see here, right, in the printf statement. So if we compile and run this one, what we get is something like this. Celsius 10 equivalent Fahrenheit is 42. Now the next question is, what if you want to do this 10 times, right? And we said if you want to repeat this 10 times, you're not going to repeat this statement 10 times. Instead, you could use a loop, right? So that is the right way to do it. So in a loop, I'm going to comment this one. So to do this using a loop, what we will do is that again we are going to define ctemp and ftemp. We will print one header for this table one time outside the loop, and then what we're going to do is that we're going to take the values from 0 to 9 and use this as the value of the ctemp, and then convert this to be stored in ftemp and then print that value here. All right, so if I compile this, what it gives us is Celsius tab Fahrenheit here, and then what happens that I becomes 0, ctemp is set to 0, which is 32 Fahrenheit as the C2F gives us, and then I go and print 0 tab 32. All right, then I go back in the for loop, I becomes 1, still less than 10, and then in that case I print 1 and the equivalent value, which is 33, 2, 3, 4, all the way up to 9 because it's less than 10. I becomes 10, which is not less than 10, and this is where the for loop stops. All right, so this is what we get. This is the output. Now the question is, what is the last value stored in ctemp and ftemp? All right, so if you ask yourself this question, you will find that ctemp has 9, ftemp has the value 41, and that's it. All right, so if you try and print ctemp and ftemp here, so something like this, all right, so I'm going to initialize this to 0 and this one to 0. All right, so let's print that, and I'm going to print just an empty line here. Compile, run. So the last value stored is 9 and 41. That makes sense. The last value stored. So what is really happening here is that every time I is incremented, ctemp gets overwritten. It becomes the new value of I. ftemp gets overwritten. It becomes the new value returned from C to F. Now, this is a problem because what if at certain point I tell you, you know what, I would like you to retrieve the data from the Celsius of 5 and its equivalent 37. Can you do that? The answer is no, you cannot do this because you don't have access to all of this data. This data gets overwritten every iteration of the loop, and you don't have any memory of this. Yes, you printed this one by one, but it's just that it's printed on the screen. You cannot retrieve it or operate on it. All right. So that's the motivation of the arrays. Why do we need arrays? You need arrays because you could store all of this data in a data structure, right? This way, later on, you could go and retrieve the data and use it for equations, for additional processing if needed. So that's why we need arrays. Now, the next question is, how can we use or how can we declare arrays and use the arrays? Now, the first thing is that you need to consider, or you need to think about arrays as an object. So arrays are objects, all right? And that's why to declare an array, you will need to use the new keyword and something that looks similar to building or declaring an object, like any other object, right? So it looks like this, okay? Int, and now this is, I'm trying to declare an array of integers, all right? Now, to tell the difference between an array of integers and the primitive data type single variable integer, you will need to tell Java that this is going to be an array. And to declare an array, you need to use an empty square bracket like this. All right, so empty square brackets, opening and closing square brackets, and that tells Java this is an array. I'm going to give it the reference variable numbers, and then later on I'm going to assign a value to it, or not a value, I'm just going to declare or reserve the memory for it. So numbers is equal to new keyword and then int again, and this time I need to give a number which is 6 places for integers. So what that does in the memory is that it goes, right, so you have the stack memory here, you have the memory here, you have numbers, which has an address, and that is pointing to a structure in the heap memory, which has 6 places, like this. All right. So these are the 6 places pointed at by numbers. All right. So again, similar to objects, you could actually declare and assign at the same line. So int square brackets, numbers is equal to new int 6. All right. So that now for any primitive data type, you could do the same thing. Float, char, long, double, anything, byte, whatever you want. You could build an array of that data type. All right. And it follows the same structure. The name with square brackets to say that this is an array, reference variable, new keyword, and again the data type with the number of elements in each of the arrays. All right. Now this number must be provided. You have to define the number of elements that you are going to have in your array. Now when you think about it, now since all of these places are pointed at by the name variable numbers or reference variable numbers, there should be a way to distinguish between this element and that one. All right. And this way to distinguish between them, what we want or what we use is something called the index. All right. The indices starts for an array starts from the element 0, 1, 2, 3, 4, 5. All right. So if you have 6 elements, you start from 0, you stop at 5. So this is how you say inside this data structure numbers, that is an array, element 0 contains X, element 1 contains Y, element 2 contains Z, and so on. All right. And of course, for us, the way we declared this, these values X, Y, Z must be integers. All right. Now, one thing that, as I said here, is very important as you declare the array size is that you have to define the array size. You have to provide a number. You cannot leave it empty or dynamic. You cannot just go and add elements to your array. So that's why you have to set that number of elements before you move on. Now, this number has to be non-negative. Of course, that makes sense. All right. And the other thing is that this number could be hard-coded as an integer. It could be a value that you hard code as a let's say a constant like this, right? It could be even a variable that you declare and then go and prompt the user for an input and then take that input and use it as a variable to set the size of an array. So that's very flexible. All right, so the fixed things that you need to provide the number, how you provide the number is completely up to you, whether it's hard-coded value or a number that you define as a constant or a number that you prompt the user for. So that's how you define or declare an array of integers or any data type. Now, one thing you need to keep in mind, and this is something very, very important, is that once you declare your array, the size is fixed. It cannot be changed. All right, so you define an array of 10 elements. Later on you found that, you know what, I didn't know that, but I need 15 elements. You cannot go to that old array and expand it and make it 15 elements. You can't do that. All right, so once declared, it's constant. All right, now how do you interact with the array? As we said, there are indices. Indices starts from 0 all the way to the length -1, right? So you have 6 elements. You start from 0 all the way up to 5. Now, if you want to access elements, you will need to use the reference variable. All right, so the reference variable name, you will need to use that. And then you will need to use the index. All right, so it's a combination of the reference variable plus the index. So what you want to say here, for example, numbers sub 0, all right, or numbers of 0 is equal to 20. So what you're saying is that for the array referenced by numbers, in the element 0, set it to 20. All right, so that's what you are doing here. And then what will happen is that the first location here will be populated with the value 20 as you instructed. All right. Now this single element, numbers of 0, can be interacted with like any other variable, like any other integer variable. All right. You can increment it, you can decrement it, you can add to it, you can subtract from it, multiply, find the square root of it. All right. So you can interact with this as any integer variable that you have dealt with before. So again, you can declare it, you can access it with this and assign value to it. You could retrieve it again with the same format and so on. So I think at this point, as we said, they are always starting from 0 and they stop at array length -1. So you have, if I declare something like this, new int 10, this tells me that this is going to be, that is not good. Here there should be a square bracket. So here it's an array of integers that has 10 elements, and then I know automatically the indexing will go from 0 to 9. All right, so it's from 0 to n-1. And one way to interact with it is to use the indices of the or the counters of the loops, and this is something we will discuss. All right, so that's a good point to stop and try to get some practical example here. So let's go back to our problem, all right, which is how to do that conversion of the Celsius to Fahrenheit, but this time we want to keep the values. All right, we want to store these values. So to store the values, what I'm going to do is I'm going to define or declare two arrays of double. All right, so double square brackets, ctemp and ftemp, both of them are 10 values that goes from 0 to 9. Then again, I'm going to print the header, and then here I'm going for int I is equal to 0 all the way up to 10, which is going to go from 0 to 9. The first thing here I'm doing is that I'm saying ctemp of I is equal to I. So what I'm saying is that I'm saying when I is equal to 0, I would like to access the 0th element of ctemp, assign to it the value I, which is 0. Then go access the ith element, which is the 0 element of the ftemp, all right, and assign to it the conversion of ctemp of I. So here I'm accessing, I'm changing the value, I'm assigning a value to it. Here I'm retrieving the value so I can pass it as an input to C2F. This way it gets converted, and then this value is going to be assigned to the ith element of ftemp. All right, and then I keep doing this, and every time I access ctemp of I and ftemp of I. All right, now if I compile this, it's going to work the same way. Now to understand what really happened here, all right, let's have a quick look at this. Right. So if you think about it, what happened is that we have again our here ctemp, ftemp, address 1, address 2. This is pointing to something which is going to be an array that goes something like this, and here we have the same, another array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and both of them are going to be indexed from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I had an extra 2, 3, 4, 5, 6, 7, 8, 9. So we don't really need that last box here. All right, then what happens is that I is equal to 0. Then I say ctemp of I is equal to I. Now at this point, I is equal to 0, right? So this means ctemp of I, so ctemp of 0, which is this, or ctemp sub 0, which is this here, is going to be assigned the value I, which is 0. All right, Then C2F is going to take a double value as an input, which at this point is ctemp of 0. So ctemp of 0 is this one. I'm going to retrieve it and then pass it as an input to C2F. And then whatever conversion I will get, I'm going to store it in ftemp of I. So ftemp of I is ftemp of 0, which is here. And I'm going to assign the value that will be returned from C to F, which is going to be 32. Right? Then I'm going to print that ctemp of I and ftemp of I. Now, I gets incremented, it becomes 1, store here 1, and then I take that 1, pass it as an input, retrieves the ctemp of 1, and then pass it as an input to C2F, and then store the value here, which is 33. And then I keep doing that. Now, to show the significance and the power of the array, the key here is that I could go even after this loop, and here at this point I could just go and say, you know what, I would like to retrieve the 5th element of that array. All right, so 5th element of the array is going to be, holding the wrong pen. So here 0, 1, 2, 3, 4. All right, so that's the 5th. So 1, 2, 3, 4, 5. So that's the 5th element of the array, right? So I would like to access this at this point here. So again, I'm going to print that empty line here just to show the difference, and then we are going to compile and run. So you see 436. I didn't have to convert ctemp of 4 to become ftemp of 4. I just could go and access them. They are stored in the memory. I could retrieve the data whenever I want. So that's the power of using arrays. That's why we would use arrays in our code. All right, so that's how to declare it, how to use it. Couple of things that we need to be very careful with is that one very common problem with dealing with arrays is knowing the boundaries. It's very possible and it's very easy to do the mistake of going beyond the array boundaries, and this is going to give you an exception that is going to complain about going beyond this value. So for example, here I have integer array numbers that goes, it has 100 places, and then I go from 1 to 100, and then let's have a look here. All right, so I go from 1 to 100, and then I try to assign the value here. Now notice here that the indices of numbers go from 0 all the way to 99, right? Now in the for loop, I started from 1 and went all the way to 100. Notice here that this is 100 counts, right? From 0 to 99 is 100 counts. And now what I did here is that I shifted I starts from 1 and ends at 100, which is still 100 counts. That's perfect. However, I go and try to access the data in this array from 1 to 100. This is where the problem happens. You're trying to, so you shifted, so you're starting from 1 to 100. So here you're shifting the whole thing to the right by 1, and then at the end, so it doesn't matter if you skip the first one. You don't have to access and populate the array in order. That's completely up to you. But the problem will happen is that when you get to the end of the array and you try to access the 100th element, this doesn't exist, right? Or the element with the index 100, this doesn't exist. So that's why it's going to give you the array index out of bounds exception. All right, so that's a very, very common array. So if you see something like this, this probably means you tried to access something that doesn't exist in the array. Another couple of so we are going to cover a couple of small things related to arrays just to get familiar with it. If you have an array that is small, all right, very few elements are there and you know them a priori, what you could do is that you could go and hard code the values immediately. So you could, instead of having separate assignment statements, you could just go and hard code the whole thing like this. All right, so you could go and now, does that mean that it has to be like this for the rest, like for the rest of the code? So days, for example, I couldn't go and change it? You could. All right, so to show you an example here, so this is systems, and I'm going to say days of 4, right? Compile. So what do we expect? Days of 4, what is that going to be? It's going to be 0, 1, 2, 3, 4. It should print 31. Perfect. Now, after hard coding here, notice the curly braces I used. I'm just hard coding, and this automatically going to set days length to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 elements. All right. So I could go and access 11 here, the 11th element. It will give me 31. Try to access the 12th element. You get an error. Perfect. Now the other thing is that what I want to say is that you could actually go and say, for example, here days of 11. So the 11th element in this array is going to be 100. All right. It doesn't fit, but we just here. So now the 11th element is going to be 100. All right. So this process of hard coding the values is just a shorthand way to set the array content. However, it's completely up to you. Later on, you could go and change them. All right. So that's a substitution of having 12 lines of this trying to assign element by element. All right. Especially if they are not consistent and cannot be assigned using a loop or something. So that's another thing to learn. The other thing that we would like to mention here is that as we said that before, each element in an array can be treated as a normal variable. All right, so you could do process on each of these elements. So here's an example of this. We have an array that we hard coded with the values 7, 8, 9, 10, 11. And that's score, and then I could go and say, for example, for the second element of score plus plus, so plus plus score sub 2, or score sub 4 plus plus. All right, notice here that this is going to actually process score of 2, score of 4. These are going to be processed. All right, so if I do something like this and I try to print 4 plus plus and then 4 here, you will notice that 0, 1, 2, 3, 4. So the fourth element is 11. When I do score 4 plus plus, that is going to make it 12. Then I go and try to print it with plus plus. What will happen is that it will print 12, but then when I print the fourth element again, it's going to give me 13. And that, if you remember, because the plus plus is going to happen after the print. So I print score of 4, which is 12 at this point. After that increment, it becomes 12. I print it, but then after printing, I immediately increment it by 1. So it becomes 13. So the next round, you try to print the fourth element, it becomes 13. Or it shows 13. So that's another thing to learn. All right, one last thing is that the way or the place where you order, so we covered this, the pre and post. The other thing that we want to learn is that there are two ways to declare arrays. You could actually put the square brackets in front the data type here, or you could put it in front of the variable name. So that is something completely up to you. You could put it here, or you could put it here. Now the thing is, this is more common. All right. However, this can be very useful. All right. So let's say you try to declare multiple arrays, all right, of the same type. So here integer, square bracket, and then numbers, code, scores, all of these are going to be arrays of integer data type. Now let's say you want to declare integers. Some of them are arrays, others are just regular variables. So in this case, instead of having int or square bracket, which makes everything after it as an array, you could just say int. And then those that are arrays, you can put the square brackets. Others that are just single variable, you could put it as is. So this way you are declaring all the integers in the single line. All right, so that's something very handy and very neat here to do. So both options are available. We covered this, and the last thing is that you could actually use, and we will see a lot of these in the next lecture. You could use the elements to do processes. So you could put them in relations, right? So here you have, you could actually check if the cost of the 20th element is less than the cost of, or the first element in cost. So that's something you could do. You could check if a value in one of the elements is not equal to 0. So you can process it, right? If it's not equal to 0, so this means that maybe I need to process this element, right? Do something to it. So that's also something available. So that's it for the lecture. What I'm going to do in the next the next video is to have a practical example to show how to use arrays in a practical example.